Imagine that when you turned on your TV this morning to see the news, your favorite news channel was broadcasting a warning, announcing that today's UV radiation is so high that extreme caution is advised. Residents are encouraged to limit their activities outside, and if they absolutely have to be outside, they should wear a pair of goggles and sunblock with an SPF of at least 150. This may not be happening now, but if we don't start taking care of our ozone layer, this might be the norm for future generations to come, especially for people like us who live in sunny Southern California. Today, I would like to share with you what I've learned about our ozone layer. I will cover 3 main points. First, what the ozone layer is made of. Second, what the function of the ozone layer is. And third, what we can do in order to protect our ozone layer from deteriorating so it can be restored to its normal, healthy levels. First, what exactly is the ozone layer made of? According to the EPA, or Environmental Protection Agency, ozone, or O3, is a highly reactive gas composed of 3 oxygen atoms. It is both a natural and man-made product that occurs in the Earth's upper atmosphere known as the stratosphere. As you can see, ozone is about 10 to 15 miles above the Earth's surface. Stratospheric ozone is formed naturally through the interaction of solar, ultraviolet, or UV radiation with molecular oxygen, or O2. Ozone is made naturally by UVC radiation striking an O2 oxygen molecule, causing it to split into 2 free oxygen atoms. The free oxygen atoms collide with an O2 oxygen molecule, creating O3, or ozone. The ozone reduces the amount of harmful UV radiation reaching the Earth's surface. Some of you may be asking yourself, what is UV radiation? UV radiation is sunlight which can be put into 3 different categories: UVA, UVB, and UVC. UVA radiation, which is the least harmful of the 3, reaches the Earth's surface in greatest amount. By being the weakest of the 3, it is not strong enough to break the bonds that connect the O2 or oxygen molecules, or the bonds that connect the O3 ozone molecules. So this radiation passes through, easily reaching the Earth's surface. UVB radiation is stronger than UVA, but weaker than UVC. So this radiation is absorbed by the ozone in the stratosphere. Later on, we will talk about how this happens. UVC radiation is the strongest of the 3, but this radiation is not a problem, because it is totally absorbed by O2, oxygen, and ozone in the stratosphere. By being the strongest, UVC is able to break the bonds that connect oxygen and ozone molecules, so it is totally absorbed in the process of breaking the bonds, so it is not able to reach the Earth's surface. Now that we have an idea of what the ozone is and where it is located, we're going to look at what its function is. To put it simply, ozone reduces the amount of harmful UV radiation from reaching the Earth's surface, particularly UVB radiation. According to the American Cancer Society, UVB rays are mainly responsible for direct damage to DNA, and are the rays that cause sunburns. They are also thought to cause most skin cancers. So how does ozone layer protect us from UV radiation? If we look back, we know that UVB is stronger than UVA radiation. So by being stronger, UVB radiation can break the bonds that connect the ozone molecules together. But it is not strong enough to break the bonds of oxygen molecules, therefore making ozone the only one of the 2 who is able to absorb UV radiation. Because in the process of breaking the bonds of ozone, UVB is absorbed, is not able to reach the Earth's surface. So that is how ozone protects us from harmful UV radiation. Now we are going to look at what we can do in order to protect our ozone and help restore it back to a normal, healthy level. According to HowStuffWorks.com, most scientists agree that human activity has caused an imbalance in the oxygen-ozone cycle. More ozone breaks down than the sun can rebuild. Humans produce ozone-depleting compounds like chlorofluorocarbons, or CFCs, which are doing most of the damage. So what are CFCs? According to the EPA, CFCs are very stable compounds that are in the troposphere. They move to the stratosphere and are broken down by strong UV light, where they release chlorine atoms that then deplete the ozone layer. CFCs are commonly used as refrigerant solvents and foam blowing agents. A quote from education.com says that to raise the consciousness is the first step to begin protecting our damaged ozone layer. Everyone should be responsible for the use and abuse of certain products that have a negative effect on nature. There are many and simple ways in which we can save our ozone layer. For example, avoid buying and using aerosols and sprays composed of CFCs. Maintain air conditioning units clean, because if they do not function properly, they can emit CFCs into the atmosphere. And last, opt to buy a refrigerator or air conditioning units that do not use CFCs. In conclusion, we have gone over a couple of things that have to do with our ozone layer. We know what the ozone layer is made of and how it's made naturally in the stratosphere. We know what its function is and how it accomplishes its function by absorbing harmful UVB and UVC radiation from the sun. And last, we looked at some things that we can do in order to help protect and restore ozone to its normal functioning levels. As you can see, we need our ozone layer, and everyone should try to do their part to protect our ozone layer. Otherwise, every time we go outside, we will have to wear protective goggles like this guy. Thank you.
All right, Kent, what did you think?
I thought he had a good speech, told us exactly what he's going to talk about. He had good visuals with a lot of information on them, and with good information. The only thing was it seemed like he was reading too much rather than speaking to us, but other than that, I thought he did good.
All right, let me start with the visuals, since that's one of the things that you picked out there. I like most of the visuals. I do think, however, sometimes there's some things that don't get a very complete explanation. When you're showing how all of the CFCs break down the ozone, for instance, I think you've got like 5 sections or 6 sections up there on the one slide, and you just kind of basically put it up there for us to translate, and I think we need a little bit more explanation and detail from you about those things, some references. And there was another one that was a similar kind of thing. It's like it's the audience has to process the information instead of you're helping us understand the information using the visuals. I thought that was a little bit of a problem. But that's mainly the only criticism I have. I thought that it's very well organized. You have excellent transitions between the supporting points. You're citing all of your material very clearly. Sometimes I think you could probably make your explanations a little bit more interesting by offering some examples or illustrations of things to liven them up a little bit. I like the introduction and the conclusion, though. You had some good stuff there to make it a little bit more, amusing and entertaining, to pull us in. The idea about we'd have the UV report for the day and how much sunblock you have to put on, or going out at the end, make sure you take your goggles so that you don't lose your vision. I thought that was kind of clever, and it makes the subject dramatic and interesting there. It just needed a little bit more of that kind of stuff in the speech to enliven a little bit. Otherwise, it gets a little techy at times. And it's a short presentation. It's 6:20, something like that. And so you've got a little bit of time that you could do some more with that. And time always flies a little bit faster when you're giving the speech than when you practice it. So, all right, thank you.